Hello guys, welcome to this live session by Intellipaat. So before I start off, just give me a quick confirmation if I'm audible or not, and also if my screen is visible or not. Right, so you guys must have come across the term R programming quite a few times, and numerous questions would have popped into your head. Is it just another programming language? How is it different from other programming languages? And is it really hard to learn R programming? So today we have come up with just the right video so that you can start your journey in the field of R programming. So let's have a quick look at the agenda. So we'll start off by understanding what exactly is R programming. Then we'll work with variables in R. After that, we'll look at the different types of operators. And then we'll learn about objects in R. And finally, we'll implement flow control statements. So what is R? So R is a language developed by statisticians for statisticians. So if you want to perform any sort of statistical analysis, R should be your go-to language. Now R is also a great visualization tool. So R provides packages such as ggplot2 and plotly so that you can create stunning visualizations. Now R is an open source, cross-platform compatible software. So it's just plug and play. All you have to do is install R once and then you can start having fun with it. And since R is an open source software, you can actually modify the code and add your own innovations to it. And being cross-platform compatible, you can actually run the same R code on different operating systems. And the best thing about R is, it is a Turing complete language. That is, it can perform any task which a Turing machine can. Now that's amazing, isn't it? And this is what makes R such a powerful tool. So you can do various operations such as statistical analysis, implement machine learning algorithms, and also create stunning visualizations, all with the help of this super language called as R. So now that we know what exactly is R, let's go ahead and install R and R Studio in our systems. So we can install R from this site over here. So we can go to cran.rproject.org. Right, so we have different versions of R. So if you are using a Linux system, then you can download R for Linux. If you're using a Mac system, then you can download R for Mac. Similarly, if you're using a Windows system, you can download R for Windows. And since I'm using a Windows system, I'll click on this link. Right, so you see this link over here, install R for the first time, click over here. Now this is the latest version of R, R 3.5.1. So you have to click on it and then the download would start. Now, since I've already downloaded R in my system, I'll go ahead and cancel this. Right. Now, after you install R, you would also require an IDE so that you can perform your tasks quite easily. So one such IDE is R Studio. So R Studio is a free open source software which provides a smooth interface so that you can perform all of your operations quite easily. And you can download R Studio from this site over here, rstudio.com. So let's go to rstudio.com and download R Studio. Right, so we have entered the site. I'll click over here, download R Studio. And we see the free version over here, R Studio Desktop Open Source License. Again, I'll click on download and you see different versions of R. So again, if you're using a Windows system, this is the right link for you. If you're using a Mac system, you can download R Studio for Mac. Similarly, if you're using a Windows, similarly, if you're using a Ubuntu or a Fedora system, you can download these versions. And again, since I'm using a Windows system, I'll click on this link. Right, the download has again started. And since again, I already have R Studio installed on my system, I will cancel this. Right. So we have successfully installed R and R Studio in our systems. Now let's go ahead and understand what exactly is a variable. So simply put, a variable is a temporary storage space. So let's understand the concept of variable with this example over here. So let's say we have this cart and this cart would be our temporary storage space. Now I also have an apple with me and I decide to store this apple inside this cart on a temporary basis. Now, after some time, I decide to remove that apple and replace it with a banana. Now again, after some time, I decide to replace that banana with a mango. So this is the basic premise behind a variable. It provides a temporary storage space where we can keep on changing the values. Right. So now that we've understood what exactly is a variable, let's head on to R Studio and implement some variables. Right guys, so this is how RStudio looks like. So we have 4 panes in total. This is the script window, this is the console window, this is the environment pane, and this is the tab where we can install new packages and also build some plots. Right. So what I'll do is I will create a new variable and name that variable to be fruit, and I will assign it a value of mango. Now I will select this and paste it inside the console window. Now let me print fruit. So I get the result mango over here. And since fruit is actually a variable, I can change the value which is present inside it. So again, I will type in fruit, and this time I will assign a value of apple. So I will paste it in the console window. Now let me print fruit. So see that the initial value of mango has been replaced with apple. Similarly, I'll create the same variable and I'll change the value. So this time the value which I'm assigning this would be a banana. Let me paste it over here. Now let me type in fruit, let me print it. So we get a banana. So this is how a variable works, guys. So this is a temporary storage space where the values can be kept changing again and again. So what I've basically done over here is I have taken a variable fruit. Initially I had assigned a value mango, after which I had replaced that value with an apple, and again I had replaced the same value in the same object with banana. Right. So now that we've understood what exactly is a variable, so each variable is basically associated with a data type. So let's start off with the first data type, numeric. So a variable can store numeric values such as 5, 1000 and -33. So after numeric data types, we have the character data types. So a variable can also have character values such as these. So a character value could be either a single character Z, or it could be the word Sparta, or it could be 2 words such as hello world. Right. Now after the character data type, we also have the logical data types. So a variable can store logical values such as true or false. Now you guys need to keep in mind that in R, by convention, this needs to be in capital, right? So this keyword true is capital and this keyword false is also capital. And then we have the final data type, which is complex. So a complex data type basically comprises of 2 parts. First is the real part, and then we have the imaginary part over here. So 2 plus 5i, 30 minus 30i, and minus 100.47i, all of these are complex data types. So similarly, a variable can also have complex data types. All right. So now that we've understood what exactly are data types, let's go to RStudio and implement some variables with different data types. So I'll start off by creating a variable which would have a numeric value. So I will name this as my obj. And first I will assign it a numeric value which is 123. Now I can use the class function to have a look at the class of the object. So let me type in class, and inside this class function I will pass in the object which I've just created, which would be my obj. Right. So the class of this object is numeric. Now what I'll do is, to the same object I will pass in a character value. So let's say I will pass in the word Sparta to this. Let me hit enter. Now let me have a glance at the class of this object. Class of my obj. So now we see that the class of this object is character, right? So initially the class of this variable was numeric, but then when I had assigned a character value to the same variable, the class changed to character. Now I'll go ahead and assign a logical value to this. So let's say I assign a true value to this. Now again, let me have a glance at the class. So class of my obj. So this time this is of logical type, right? Now finally, let me assign a complex type to this. So my obj, and using this assignment operator, let's say I would give this a value of 30 plus 100i. Right. Now let me use the class function and have a look at the class of this object. So that would be my obj. Right. So the class of this object is complex. So what we basically understand from this is, as we change the type of the value given to the object, the class of the object also changed. So we started off by assigning a numeric value to the object. Then when we saw the class of that object was numeric, then we had changed the value and we had assigned the same object a character type, and that's class changed to character, right? So this basically means that if we change the value given to the variable, the class of that variable would also change, right? So these were data types in R. Now let's have a look at the different operators which are available in R. So these operators basically help us to perform some sort of mathematical or logical operations on top of our variables. So basically we have these four operators in general. So we can have assignment operators, arithmetic operators, relational operators, and logical operators. So let's start off with the assignment operators. So as you can see what is stated over here, assignment operators are basically used to assign a value to an object. And these are the three different assignment operators available in R. So we can just use the equal to operator to assign a value, or we have this another symbol over here. So here we have a less than operator, after which we give a hyphen. So this is another type of assignment operator. Here again we have the hyphen followed by a greater than symbol. This is another type of assignment operator. And if you have a look at this, we have some examples over here. So what we are doing is we are assigning the value of 10 to this variable x using this assignment operator. Similarly here we are assigning this value 20 to this variable y using this assignment operator. And similarly we are assigning this value of 30 to this variable z using this assignment operator. So again, let's head to our studio and we will be implementing some assignment operators and assigning some values to some objects. So let's say I create the same variable x. So I will put in the variable name which is x, after which I will give in the assignment operator which is equal to, and I will give in the value now. So let's say the value which I want to give this is 10, right? Now similarly I will assign a value to the variable y. So I will give in the name of the variable which is y, and then I will use another variation of the assignment operator. So first I will give in the less than operator, and then I will give in a hyphen, and the value which I give is, let's say 20. So I'm basically assigning the value 20 to this variable y, and then I will give the value 30, and I am assigning this value 30 to the variable z. So this is basically inverse assignment. So first I give in the value, and after giving in the value I would assign it to the variable, right? Now let me print x, y, and z values. So x, y, and z. So we have successfully assigned the value of 10 to variable x. We have assigned 20 to variable y, and we have also assigned 30 to variable z. Right, so that is how we could work with assignment operators in R. Now let's head on to arithmetic operators. So these arithmetic operators are used to perform basic mathematical operations. And these are the different arithmetic operators which we have in R. So this plus symbol over here helps us to add two variables. Then we have this minus symbol which helps us to subtract two variables. Then we have this asterisk symbol which helps us to multiply two variables. And finally we have this forward slash which stands for division. So with the help of this we can divide two variables or two operands. Right, now we are back to our studio and let's perform all of these arithmetic operations. So I'll start with addition first. So we had just seen that we had created three new variables x, y, and z. So we will be performing all of those arithmetic operations on these three variables x, y, and z. So I'll start off by adding these two variables. So x, which is the first operand, then I will give in the operator which is plus. After which I will give in the second operand which is y, and we get the result which is 30. So the initial value of x was 10 and the initial value of y was 20. And when we add 10 plus 20, we get the value to be 30. Right. Now similarly, let me perform another addition operation. So this time let me add y plus z. So the initial value of y was 20 and the initial value of z was 30. And when I add these two, I get a value of 50. So these were some addition operations. Now let me perform some subtraction operations. So I want to subtract y from z. So I will give in the first operand which is z, and I will give in the operator which is minus, and then I will give in the second operand which is y. So I am subtracting y from z, and this is what we get. So z is 30 and y is 20, and when I subtract 20 from 30, I get 10. Now let me subtract x from z and let's see what do we get. So this time what I'm doing is, so the z value is 30 and x value is 10, and 30 minus 10 gives us a value of 20, right? So these were some subtraction operations, after which we'll start with the multiplication operations. So let me multiply x with y, and let me see what do we get. So x value is 20, so x value is 10 and y value is 20, and when we multiply 10 with 20, we got a value of 200, right? Now similarly, let me multiply y with z, so y asterisk z, let me hit enter, so we get a value of 600 because y's value is 20 and z's value is 30, and 20 cross 30 gives us a value of 600. So these were some multiplication operations. Now let's head on to division operations, right? So let me divide z with y, and let's see what do we get. So z's value is 30, y's value is 20, and 30 by 20 gives us 1.5. Now let me do y with respect to x. So this would be 20 divided by 10, and this would give me a value of 2. Right, so these were some arithmetic operators. Now let's look at relational operators. So these relational operators are used to compare two operands. So these are all of the different relational operators which we have. So this is the less than operator, and this helps us to find out if the first variable is less than the second variable. Then we have the less than equal to operator. So this helps us to find out if the first operand's value is less than the second operand's value. Then we have the greater than operator, and this helps us to find out if the first operand's value is greater than the second operand's value. And then we have the greater than or equal to operator, and this helps us to find out if the first operand's value is greater than or equal to the second operand's value. And then we have the is equal to operator. So here we just given two equal to's, and this helps us to find out if the values of both the operands are equal. And thus finally we have the not equal to operator. So first we give in the exclamation mark, and then we give in the equal to symbol. So this helps us to find out if the first variable is not equal to the second variable. Again, let's head back to our studio and let's implement some relational operations. So let me check if the value of x is less than the value of y. So I get a true value because 10 is less than 20. Now let me check if x is less than or equal to y. Now this again is true because 10 is less than or equal to y. Now I will go ahead and check if x is greater than y. So this time I actually get a false. So this is because 10 is not greater than 20. Right. Now similarly, let me check if x is greater than or equal to y. This again is false because 10 is neither equal to nor greater than y. Now let me go ahead and check if the value of x is actually equal to the value of y. So this time again I get a false value because 10 is obviously not equal to 20. Now let me check if x is not equal to y. So this would obviously be true because 10 is obviously not equal to 20. So these were some of the relational operators. And then we have the logical operators. So the logical operators are basically used to make a decision on the basis of a condition. And the two most majorly used logical operators are the AND operator and the OR operator. So this is the AND operator. So let's have a look at this table to understand how does the AND operator work. So we have two conditions over here, and if both of those conditions are evaluated to true, only then the AND operator would give a true result. So let's take this case over here. So here the first condition is evaluated to false, and the second condition is also evaluated to false, and that is why the result which we get is false. Let's take the second case. So over here the first condition is evaluated to false, the second condition is evaluated to true. But since both of the conditions are not evaluated to true, the final result is false. Again, let's have a look at this third case. Here the first condition is evaluated to true, but the second condition is false. And that is why the final result is false. So let's take this final case. So over here, this is the only case where both of the conditions have been evaluated to true. That is, the first condition is also true and the second condition is also true. And that is why the final result which we get is true. Then we have the OR operator. So the OR operator gives us a true result when either of the conditions is true. So let's take the first case here. The first condition is evaluated to false. The second condition is also evaluated to false. And since both of the conditions are evaluated to false, the final result is false. Then we have the second case over here. Here, the first condition is false and the second condition is evaluated to true. And since the second condition is evaluated to true, the final result is true. Then we have this third case. Here, the first condition is evaluated to true, but the second condition is evaluated to false. But since at least one of the conditions is true, the final result is true. And thus obviously we get a true result because both of the conditions are resulting true. Now let's go to RStudio and implement these logical operators. Right. So let me give the first condition. So the first condition would be x is less than y. Then I will give in the AND operator and I will put in the second condition. So the second condition would be x is less than or equal to y. Now let's examine this command properly. So x is less than y. This means that 10 is less than 20, which is true. Now let's examine the second condition. So over here, 10 is less than or equal to 20. This again is true. So true and true would give us a true result, right? Now let me change the conditions. So let me give the first condition to be x is greater than y. I will give in the AND operator. Now let me put in the second condition. So the second condition would be, let's say x is not equal to y. So here x is greater than y would be yielded to false because 20 is not greater, because 10 is not greater than 20. Then let's examine the second condition. This would be evaluated to true. So 10 is obviously not equal to 20, but the final result is false because one of the conditions is evaluating to false. So this was the AND operator. Now let's work with the OR operator. So again, let me give in the first condition. So the first condition would be x is not equal to y. Now let me use the OR operator and let me give in the second condition. So the second condition is, let's say x is greater than y. So guys, what do you think would be the result over here? So we get a true value. This is because the first condition yields a true value. So 10 is obviously not equal to 20. But even though the second condition is yielding false, since we have at least one condition which is yielding true, the final result is also true. Now let me do a variation over here. Now let me give in two false conditions and let me see what will happen. So the first condition would be x is greater than y. Then I'll give in the OR operator and then I'll give in the second condition. So let's say the second condition is x is equal to y. So this time we get a false value. This is because first condition is false, the second condition is also false. And when we use OR operator with two false conditions, the final result is obviously false. Right, so these were some of the operators in R. Now let's go ahead and understand objects. So basically every data element in R is an object. As simple as that, guys. I'm reiterating it. Every single data element is basically an object in R. And these are the 6 most basic used objects in R. So we have a vector, matrix, factor, list, array, and a data frame. So let's start off with the most basic object, which is a vector. So a vector is actually a linear object which contains elements of same type. So elements of same type, or in other words, elements which are homogeneous. And this is the syntax to implement a vector in R. So you will be using the C function or the combine function and you will be passing in all of the elements. Right? So over here, I am using the C function to pass in 3 elements, which are the numbers 1, 2, and 3. And similarly over here, I am creating another vector where I'm passing in 2 elements, which are true and false. So let's go to RStudio and create some vectors. Right. So I will create a vector and I'll name that vector to be my vector. Now using the assignment operator, let me assign some values to this. So I'll be giving only the elements of same type. So let's say I will give in elements of only numeric type this time. 1, 2, and 3. So this vector comprises of 3 elements, and all of those 3 elements are of numeric type. So let me have a glance at the class of this. So class of my vector. So we see that this is of numeric. Now what I'll do is, to the same my vector object, I will assign elements of different type. So this time I will be passing in elements of character type. So let's say the first element is character A, the second element is character B, and the third element is character C. Let me hit enter. Now let me have a look at the class of this. So class of my vector. So see that this time it is a character. Now again, to the same object, which is my vector, let me assign logical values. So the logical values would be true, false, and true. Now let me check the class. So that would be class of my vector, and this is logical. So you see that the class of the vector is basically determined by the elements which are passed to it, and all of the elements are basically homogeneous. Now what I'll do is, I'll actually pass in elements of 2 different types to the same vector, and let's see what would be the result. So the name of the vector is my vector. I will use in the C function or the combine function, and this time what I'll do is, I will pass in 2 numeric elements first, and after passing in 2 numeric elements, I will pass in 2 logical elements, true, false. So this is a vector which comprises elements of different types. So the first type is numeric and the second type is logical. So guys, what do you think would be the result? So do you think there would be an error, or we would be getting some other result? So let's see what we'll actually get. So let me print in my vector over here. So this is quite a strange result, isn't it? So we had actually passed in 1, 2, true, and false, but the result which we are getting is 1, 2, 1, and 0. This is because the logical values have been coerced to numerical values. So this means that a vector can have only homogeneous values. So the value of 1 and 2 are the same. So 1 is a numeric value, it remains as 1. 2 is a numeric value, it remains as 2. But this true logical value over here, this has been coerced to a numeric value of 1. Similarly, we have this false logical value over here, and this has been coerced to a numeric value of 0. Right. So this time I will pass in character values and logical values to the same vector. Let me name that vector to be my vector, and let me use the C function to assign some values. Right. So let's say the first 2 elements are characters. So the first element is the character A, and the next element is the character B. After this, I will give in 2 logical values. Again, there would be true and false. Now guys, what do you think would be the result for this? So let me just check. So that would be my vector. Right. So this time the logical values have been coerced to character values. So A and B were initially character and they remain as character. But these 2 values which were actually logical, their values have been coerced to character. So just to verify it, let me show you the class of this character. So class of my vector, this is a character. So even though I had passed in 2 character elements and 2 logical elements, the class of both of the logical elements has been changed to character, and the class of the entire vector is also character. Right. Now finally I will pass in all of the elements of the 3 different types. So I will pass in 2 numeric values, 2 character values, and 2 logical values. So I will pass in 2 numeric values which are 1 and 2. After this I will pass in 2 character values which are A and B. And then I will finally pass in 2 logical values which are true and false. Now let me hit enter my vector. So this time all of the values have been coerced to character. So this means that character data type has the highest precedence, then numeric values has the next highest precedence, and the Boolean values or the logical values would have the lowest precedence. Right? So again, just to verify, let me show you the class. So that would be class of my vector. So this is a character. So even though we had passed in elements of 3 different types, the class has been changed to character. So let me print in my vector again over here. So these are the 6 different elements which are present in this vector. So now I'll go ahead and show you guys how to extract individual elements from this character. So let's say I'd want to extract this 4th element from this vector. So let's go ahead and do that. So for that, I would have to give in the name of the vector first, which would be my vector. After that, I will give in 2 square braces. And inside that square braces, I will give in the index number. So the index number is 4 over here. So the numbering starts from 1, guys, right? So this is index number 1, 2, 3, 4, 5, 6. And since I want this element over here, the index number would be 4. Right. So this is how we can extract the element B from this vector. Similarly, if I wanted to extract this 6th element over here, all I have to do is give in the name of the vector, which would be my vector. I will give in 2 square braces, and inside that I will give in the index number, which would be 6. Right. So we have extracted this false value. Now let's say we wanted to extract only the alternate values or the alternate indexes from this vector. That is the 1st, 3rd and the 5th values from this entire vector. So for that, I would have to give in the name of the vector. Then I'll give in 2 square braces, and using the C function or the combine function, I'll be selecting the 1st, the 3rd and the 5th index. Right. So from this entire vector, I have extracted the 1st element, the 3rd element and the 5th element. Now similarly, if I wanted to extract all of the elements starting from index number 2 to index number 5, this is how we can do it. So I will type in my vector over here. I will give in square braces. I will put in the 1st index number, which is 2, and then I will put in a colon, and then I will give in the last index number, which is 5. So like this, we can extract all of the elements starting from one particular index to the last index. So let me hit enter. So we have extracted all the elements starting from index number 2 to index number 5. So that is how we can work with that. So that is how we can work with vectors. So next we have lists. So list is actually similar to a vector, but the only difference is a list can contain heterogeneous elements. That is, even though if you pass in elements of different types to the same list, they will be not coerced to the data type of higher precedence. So let's take this example over here. So this is how you can create a list. So first you will use in the list function, and then you will give in the individual elements. Now we see that one element is of numeric type and the other element is of character type. Now even though this is of numeric, this will definitely not be coerced to character type. So this is the speciality of a list. So you can pass in heterogeneous elements where the heterogeneous elements will not lose their core identity. Right, so let me create the first list and name that list to be my list 1. And I'll use the assignment operator again. I will use the list function. Right, now using the list function, what I'll do is I'll pass in 3 different elements. So the first element would be a numeric value 1. The next element would be a character value A. And the third element would be a logical value true. Let me hit enter. Now let me print out the list. So let me show you guys how does a list look like. So my list 1. So guys, this is how a list looks like. So see that there are 3 different components over here. There's the first component, second component and the third component, right? So this first component contains the numeric value 1. The second component contains this character element A, and this third component contains this logical element true. Now let me show you guys the class of each of these individual elements. So let me show you how to extract individual elements first. So my list 1. Now let's say I would want to extract the second component. So if I want to extract the second component from the list, I will give in square braces. Now inside the square braces, I will give in another set of square braces. Now inside this, I will give in the component number. And since I want the second component over here, I will put in 2. So this is how we can extract the second component from this entire list. Now let me have a glance at the class of this. So class of, I'll give in the name of the list, which is my list 1. I'll put in 2 braces. Inside the braces, I'll give in another set of braces. And let me give in the component number, which is 2. So you see that this is of type character. Now similarly, let me check the class of this component over here. So the component would be 3. So the class is logical. Now let me check the class of this first component over here, which is 1. So numeric. So you see that even though we are assigning elements of different type, these elements are holding on to their true classes or to their true data types, right? So the numeric value stays as a numeric value, the character value stays as a character value, and the logical value stays as a logical value, right? So now I'll go ahead and create another list. So I will name this list to be my list 2. And this time what I'll do is I'll use the list function and I'll pass in 3 vectors inside this list. So I will pass in a numeric vector inside this. So I'll use the C function, and the numeric vector would comprise of these 3 elements 1, 2, and 3. After this will comprise of a character vector, and the character vector would comprise of A, B, and C. So let me change this to small b over here. Then I'll pass in the third vector or the third component. So the third component would comprise of logical values, and the logical values are true, false, and true. Let me hit enter. Now let me print out this list. So let's see what do we get. So it's my list 2. So this is the list, guys. So this is the first component, this is the second component, and this is the third component, right? So the first component contains a vector of 3 numeric values. The second component contains a character vector of 3 different individual characters. Then we have the third component, which contains a vector of 3 logical values. So now let's understand how can we extract individual elements from this sort of list. So let's say I wanted to extract this element from this entire list. So this element is present at the second location of the second component, right? So first I would have to give in the name of the list, which would be my list 2. After this I will specify the component. So 2 square braces. Inside that I will give in another set of square braces. So now let me specify the component number, which is 2. After this I will give in the element position. So in the second component or from the second component, I would want the element present at index number 2. So I will give in 2 over here. And we have successfully extracted this value. Now similarly, let's say if I wanted to extract this true value from this third component. So this is element number 1 at component 3. So I would have to give in the name of the list, which is my list 2. So I'd have to specify the component number. So the component number is 3. Then I'd have to specify the position where the element is present. So it is present at first position. So from the third component, I am extracting the first element and we get the true value, right? So this is how we can work with lists. Now let's go ahead to the third object, which is a matrix. So matrix is not actually a linear object. It is a 2-dimensional object. So when I say 2-dimensional object, it would have both the rows and the columns. And this matrix would contain only homogeneous elements or elements of similar type. And this is how you can create a matrix. So we can use the matrix function. So this matrix function first takes in the data where all the elements come from. After this, we specify the number of rows present in the matrix. So this is the result for this command over here. So when we specify the number of rows to be 2, we get the number of rows to be 2 over here, right? So this is how a matrix looks like. So we have rows and we have columns, and all of these elements are coming from this data over here. So let's head to our studio and implement a matrix. So let me use the matrix function. I'll type in matrix over here. Then let me pass in the data. So the data which should be present in the matrix should be coming from this vector. And this vector would be comprising of the elements 1, 2, 8. So let me hit enter and let's see what do we get. So this is the matrix which we get. So we have 8 rows and 1 columns. So if we do not specify the number of rows in the matrix, then it automatically assigns each element to a new row. So since we have 8 elements over here, we have 8 rows and 1 single column. So let me go ahead and use the n row parameter to set some predefined number of rows. So let's say I'd want 2 rows in the entire matrix. So the n row value would be 2. Right. So this is our matrix, guys. So we have 2 rows and 4 columns. Now what you see over here is these elements are arranged with respect to column and not with respect to row. That is, so this is 1, 2, 3, 4, 5, 6 and 7, 8. These are arranged with respect to the column. So if I wanted these to be arranged with respect to the row, I have the by row attribute and I will set this by row attribute to be true. So these elements which were actually aligned with respect to the column now have been aligned with respect to the row. So 1, 2, 3, 4 are in one row and 5, 6, 7, 8 are in another row. So I will store this in a new object and name that object to be mat1. Right, now let me print mat1 over here. So this is a matrix. Now let's understand how can we extract individual elements from this matrix. So let's say I wanted to extract this element over here. So this element is present at row number 2 and column number 3. So again, I would have to give in the name of the matrix, which is mat1. Then I will give in the square braces over here. Inside the square braces, I will first specify the row number. So the row number is 2. Then I'll put in a comma. After that, I will specify the column number. So the column number is 3. Let me hit enter. Right, so this is how we have extracted the element or the value 7 from this entire matrix. Right, now let's say I wanted the element this 5, 7 and 8 from this matrix. So let's do that. So again, I would have to give in the name of the matrix, which is mat1. After that, I will give in 2 square braces and from the second row. So the row number is 2, which I'd given, and I would require the element which is present at column number 1, 3 and 4. So I will use the combine operator and I will specify the column values which are 1, 3 and 4. Right? So this is how we can extract these individual elements. And similarly, let's say if I wanted to extract this entire row from this matrix. So for that, I would have to type in the name of the matrix, which is mat1. I will use the square braces. So I will give in the row number, which is 1. And since I don't want all of the columns from this row, I'll not assign anything over here. So I'll just leave it to be blank. Right? And voila, we have extracted all of the elements which are part of the first row. Right, so that is how we can work with a matrix. Next, we have an array. So arrays are basically just an extension to a matrix. So matrix was a 2-dimensional object. So arrays, since they are an extension to matrix, they have more than 2 dimensions. And the elements which are stored in an array, they are all homogeneous. So this is the syntax to create an array. You use the array function and then you pass in the data values. After that, you set the dimensions. So this, what you see over here, 3, 3, 2. So this basically tells you that we will be getting 2 matrices which would have 3 rows and 3 columns each. Right, so if this seems too confusing to you, let's go to R and let's actually create an array by ourselves. So to create the array, let us first create the vectors which would be passed in as the data elements inside the array. So let me create the first vector. I'll name that first vector to be v1. And the values in this vector would be all of the numbers starting from 1 to 8. Now I will create another vector and name that vector to be v2. And the elements which would be there in this vector are the numbers starting from 9 to 16. Let me hit enter again, right? So let's have a glance. v1 is all the numbers from 1 to 8 and v2 is all the numbers from 9 to 16. Now I can go ahead and create the array. So I will use the array function. Now let me give in the data. So the data is coming from those 2 vectors over here. I will use the C operator to combine those 2 vectors. First vector is v1, second vector is v2. So we have successfully given the data. Now let me set the dimensions. Right. So let's say I would want 2 matrices where I have where I want each matrix to have 2 rows and 4 columns. So I will use C. So I will give in the first value, which would be for the row. So I would want 2 rows, I would want 4 columns, and I would want 2 such matrices. So this is what we get. So this dim value of 242 basically states that I have 2 matrices which are of 2 cross 4 type. So each of these matrices has 2 rows and 4 columns. So let me store this in a new object and name that object to be ARR1. Let me print ARR1 now, right? So this is our resultant array. Now let's understand how can we extract individual elements from an array. So again, I would have to give in the name of the array, which is ARR1. Then I will give in the square braces, and inside these square braces, let's say I'd want to extract this element over here. So this element is present at second row, second column of the second matrix, right? So these would be the values. So I will give in the row number, which is 2. I would give in the column number, which is also 2. Then I will give in the matrix number, which is also 2, right? So we can extract this element like this. Now let's say I would want to extract this element value 8 from this entire array. So this is present at row number 2, column number 4, and matrix number 1. So let me give in the name of the array, which is ARR1. So I will give in the row number, which is 2. Then I will give in the column number, which is 4. Then I will give in the matrix number, which is 1. Right? So we have extracted this element value 8 from this matrix. So this is how we can work with arrays. And then we have something known as a factor. So factors are basically objects which are used to categorize the data. So let's take this example over here. So we have a character vector over here, but in this character vector, we have the same element value repeating twice. So we have male, female, female, male. So we have male repeating twice and female repeating twice. So this basically means that we can convert this into a categorical variable. That is, we can convert this into a categorical variable which would have 2 categories. So the first category would be male and the second category would be female. So this is where the factor objects come in. So what we'll do is we will take this character object, we will put this character object as a parameter, the as.factor function, and then we can convert this into a categorical variable or a factor variable. So let's go to our studio and work with some factors. So now what I'll do is I'll create a vector once. So that vector would comprise of 3 character elements x, y, and z, and I will repeat those same values 5 times. And to do that, I would require the REP function, which stands for repeat. So inside this repeat function, I am creating a new vector which would comprise of 3 character elements. So the first character element is x, the next character element is y, and the third character element is z. So we have 3 character elements. Now what I'll do is I will be repeating these 3 elements 5 times. So let me hit enter. Right? So what you see is x, y, z is being repeated 5 times. So this is once, twice, thrice, 4 times, and 5 times. So now I will store this in a new object and I'll name that object to be my data. Let me check the class of my data. Class of my data. Right, so this is a character. Now since we already know that this character vector has 3 different categories, right? So let me print in my data again, right? So this character vector has 3 categories which are being repeated again and again, and these 3 categories are x, y, and z. So now if I wanted to convert this character vector into a categorical variable, all I need to do is use the as.factor function. Inside this as.factor function, I will pass in the my data variable and I will store it back to my data. Now let me have a glance at this class of my data. So this time we see that this is a factor. Right, now let me print my data. Let's see what is the difference, right? So see that these are all of the elements and the elements have been segregated, right? So we have 3 levels, x, y, and z. Okay, so this was how we can create factor objects in R. And then finally, we have a data frame. So data frame is basically a 2-dimensional structure where we can have heterogeneous elements. So here, each column can comprise of only homogeneous elements, while a row can either contain homogeneous or heterogeneous elements. So, and this is the command to create a data frame in R. So we will use the data.frame function, and inside this data.frame function, we can create different columns. So here what we are doing with this command is we are creating two new columns. So I am naming the first column as name, and the values which would go in the first column are Sam and Bob. The name of the second column is age, and the values which would go into the second column are 32 and 48, right? And this is the resultant data frame which we get. So we have two columns. The first column is name, the second column is age, and the values under name are Sam and Bob, and the values under age are 32 and 48, right? So now let's go to R and create a data frame by ourselves. So now what I'll do is I want to create a data frame which would be comprising of two columns. The first column would comprise of names of fruits, and the second column would comprise of the cost of those fruits. So I will use in the data.frame function, and I will name the first column to be fruit name. Now let me assign values to this first column by using the C function. So let's say I want three fruits over here. So the first fruit would be mango, the second fruit would be apple, and the third fruit would be banana. So now we have created the first column. After this, we'll go ahead and create the second column. So the second column would be fruit cost. So let's assign some cost to those three fruits. So the first cost value would be, let's say, 105. The second cost value would be 57, and the third cost value would be 80. So now I will store this in a new object and name that object to be fruit. Let me have a glance at fruit now. So we can use the view function to have a glance at a data frame. So view of fruit, right? So we have successfully created this data frame which would comprise of these two columns. So the first column is the name of the fruit, and the second column is the cost of the fruit. The first column comprises these three values, mango, apple, and banana. And the second column comprises these three values, 105, 57, and 80, right? So now we'll learn how to extract individual columns from this data frame. So let's say I wanted to extract this fruit cost column from this data frame. So for that, I would have to give in the name of the data frame first, which is fruit. After that, I will use in the dollar symbol, and using that dollar symbol, I will select that column which I want to extract. And since I want to extract this fruit cost column, I will select this. So what I'm basically doing is, from the fruit data frame using the dollar symbol, I am extracting the fruit cost column. So let me hit enter, right? So we have successfully extracted this column from this data frame. Now let's also understand how can we extract individual values from this data frame. So let's say I wanted to extract this value from this data frame. So this value is present at third row, second column. So if I wanted to extract that cell value present at third row, second column, then I'd have to give in the name of the data frame first, which is fruit. I will give in square braces. First, I will give in the row number, which is 3. Then I will give in the column number, which is 2. Let me hit enter. All right. So we have extracted the cell value from this data frame over here. So these were the different objects with which we could work in R. Now let's head on to decision-making statements. So decision-making statements basically help us to impose a condition, and on the basis of that condition, execute some statements. So in general, we basically work with these two decision-making statements. So we have if and if else, right? So now let's start with if. So this is how the if statement works. So first, we will give in the condition and check if the condition is true or false. So if the condition is true, then the rest of the statements will be executed, else nothing will be done, right? So this is how the if syntax works. So we'll give an if over here, we will give in the condition, and if this condition is evaluated to true, only then some sort of action is done, else nothing happens at all. Okay. So let's go to our studio and work with the if statement. Right, so now what I'll do is I will actually create a new vector and name that vector to be check decision. And inside this vector, I will give in 6 numeric values, which would be 10, 20, 30, 40, 50, and 60. Right, so we have our check decision vector ready. Let me hit enter. Right, so we have this vector ready. Now, let me use the if statement to find out if the element present over here, the value of the element present over here is greater than 30 or not. And if the value is greater than 30, I will perform some action. So I will type in if over here, then I will give in 2 braces. Inside this, let me give in the condition. So the condition would be check decision, and I am checking if the element value, this value which is present at index number 3. So if the value present at index number 3 of this check decision vector is greater than 30, then I will print out the element present at index 3 has value greater than 30. Now let me select all of this and let me print. Let's see if we get something or not. So guys, we don't get anything, so we don't get a result. So why is it that you think? So this is because this condition has been evaluated to false, right? So the third element was exactly 30. So let me print check decision over here. So this is the first element, second element, and this is the third element in check decision. So over here, the condition is if this element's value is greater than 30, only then we will print this, else nothing will happen. And since 30 is not greater than 30, nothing is happening over here. Right. So now let me make a small alteration over here. So what I'll do is I am checking if the element present in the third index, the value is equal to 30. And if the value is equal to 30, I will print the element present at index 3 has value equal to 30. Let me select this command. Let me paste it over here. Right. So this time, this condition is evaluated to true. So the index which is present at 3 has the value 30. And since this is evaluated true, that is why this statement has been executed and we get the result. The element present at index 3 has value equal to 30. So that was the if statement. Now let's look at the if-else statement. So the problem with the if statement was if this condition was evaluated to false, nothing else was happening. So this is where if-else statement comes in. So here what we do is we check the condition first, and if that condition is evaluated to true, we do certain set of actions. But if the condition is evaluated to false, we do an alternate set of actions. So we just don't leave it out there, right? If the condition is evaluated to true, we perform first set of actions. If the condition is evaluated to false, we have an alternative set of actions. And this is the syntax for that, right? If condition, this is evaluated to true, then these statements are executed. Else, or in other words, else the condition is false, then the statements below this are executed. Right. So now let's use the if-else statement. So now I'll be working with this same check decision vector. So now this time what I'll do is I'll be using the if-else clause and I will check if this value is greater than 30. And if this value is greater than 30, I will print value is greater than 30, else I will print value is not greater than 30, right? So it's a very simple thing, guys, right? So I am using the if statement over here, and over here I will be using the vector which is check decision, and I am checking if the element 3 of the check decision vector, the value is greater than 30. And if the value is greater than 30, I will be printing value greater than 30, else I will print value not greater than 30, right? So now let me select all of these and let me paste it over here and let's see what is the result. Right. So we get value not greater than 30. So what has happened over here is, so we have checked the condition, this condition evaluated to false. And since this condition evaluated to false, we will come to this else block over here. So this else block is printing value not greater than 30. Right, so these were some decision-making statements. Then we have looping statements. So the looping statements basically help us to iterate a certain task, right? So I'm repeating it again. The looping statements, as the name states, they help us to loop a certain set of actions or iterate or repeat a certain set of actions. And the two most commonly used looping statements are for and while. So let's start off with the for looping statement. So this is how this works. So we have the syntax over here, for variable in vector, and then these are the statements which are executed. So what we are basically doing is we will extract the first element from the vector, then we will perform certain set of actions, and then we'll check have we reached the last element or not. So if we haven't reached the last element, we'll go back, we'll extract the next element, we'll perform the same set of actions, and then again we'll check if we have reached the last element. And this process goes on till we have reached the last element, right? So let's go to RStudio and implement a for loop. So this time what I'll do is I'll create another vector and I will name that vector to be check loop, and the values which I'm assigning to check loop would be 100, 200, 300, 400, 500 and 600. So let me print check loop over here, right? So we have a vector ready. So now this time using the for loop, what I'll do is I will be adding 50 additional. So I'll be adding additional 50 values to each of these elements, right? So this 100 will be turned into 150, 200 will be turned into 250, 300 to 350, this to 450, this to 550, and this to 650. So let's do that using the for loop. So I will use for, and we automatically have the snippet over here. So first I need to give in the variable name which would parse through the vector. So let's say I name it to be I, and the vector which I need to iterate through would be check loop. So this I would start from index value 1, and this will iterate through the entire vector. And after iterating, what I'm going to do is I'm going to add a value of extra 50 to each of these elements. So print of I plus 50. So let me explain this properly. So what will happen is for I in check loop. So for I in check loop, initially the value of I would be 100. And since the value of I is 100, I am adding another 50 to this, and the result would be 150. Right. So once this is done, I am going back and I'll check if I've reached the last element or not. No, I've not reached the last element. So the next element is 200. So now I'll take in that 200 and I'll add another 50 to it. So the value would be 250. Next, I'll go back and check if I have reached the last element or not. Again, I have not reached the last element. So this time the next element's value is 300. So this time I'll print 300 plus 50, right? So this is how it'll go on till the last element is encountered. So let me select all of this. Let me print it over here. Right. So this is the result. So initially we had 100, 200, 300, 400, 500 and 600. And those values have been changed to 150, 250, 350, 450, 550 and 650 using the for loop. So up next we have the while loop. So let's understand how this while loop works. So here first the condition is evaluated, and if the condition turns out to be true, then this certain set of actions are done. And if this condition is evaluated to false, we exit out of the loop. So let's say we keep repeating this till the loop or the condition is evaluated to true, right? So I'm repeating it again, guys. So this condition or the loop will run till the condition is evaluated to false. So as long as the condition is true over here, this loop will continue to go on. Right, so let's implement a while loop over here. So I'll be working on the same check loop vector, and this time what I'll do is I'll add additional 100 to the same elements. So I will use while and I will give in condition over here. So the condition would be while I is less than length of check loop. So now here I will not automatically get a value. So you would actually have to initialize the value of I. So let's say the initial value of I is equal to 1. And let me actually set it to be I is less than or equal to length of check loop, right? And if this as I is less than or equal to length of check loop, what I'll do is I will add additional 100 to this. So print of check loop, I'll use the square braces. I will pass an I over here and I will add additional 100 to each element. Then I would also have to increment the I value with 1. So let me go through this again, right? So initially I am assigning the value of I to be 1. So here what is happening is, so this would actually be 1 is to length of check loop, right? So this would actually, so this would be the same, guys. I is less than or equal to length of check loop, right? So what we are doing is first we are checking if the value of I is less than the length of this. And since there are 6 elements in total, 1 is obviously less than or equal to this. And since this is less than or equal to this, we will be printing the first element and adding 100 to this. After that, we'll be adding 1 more to the I value and then check if the I value is less than or equal to the length of the check loop. And this goes on till I value is greater than the length of check loop. So let me select all of this and let me paste it over here. Right. So this is what we get over here. So this is how we can work with the while loop. Right, guys. So this brings us to the end of this session. Thanks for attending very much. So if you have any questions, you can drop it down in the comment section and our team would get back to you as soon as possible. So now, if you're interested, let me actually guide you through the Data Science with R course which we have. So this R programming tutorial was a part of the R programming for data science training course. And this is our training course, guys. And this is all what you'll be learning if you enroll for this course, right? So you'll be learning all about data frames, matrices. You'll learn how to generate plots. You'll learn k-means clustering, association rule mining, regression in R, logistic regression, right? So if you enroll for this course, you can learn all of these things. So we'll be actually sending a form to you guys and let us know if you'd be interested to join the course or not. And if you want to go through some other R programming tutorials, so this is the link for it. So you can go through these R programming tutorial. So thanks very much for attending the session, guys.
Hello. Yeah, hello, good evening, everyone. So, actually, my name is Amit. I'm a senior course advisor from Intellipaat. So, I think you have already the session regarding R programming. So, who is interested for this particular course, obviously, we'll send you the form to fill up your details. And obviously, you'll be getting a best discount for this particular course. And let me tell you one thing about this particular R programming. What is the benefit if you learn this right now? And the currently 2019 has been ended, and you will see data science domain where R programming is used very widely. Okay, whether right now you're a fresher or experienced currently in the industry. So if you learn the data science for the next 5 years or 10 years down the line, okay, R programming is widely used being a programming language in the industry. Okay, and obviously getting a job also is very easily in this particular domain to start your career in data science. So basically we this particular provide this R programming training especially focused on a data science domain. Is from a basic level, from a scratch level to advanced level. Okay, and this particular online session happens mostly on a weekend or a weekday. Okay, so basically this particular session will be through a GoToMeeting session. We provide a go-to session meeting link on your email ID, the registered email ID, probably on a Saturday, Sunday, or any weekday batch. And the timing for a weekend is 8 p.m. to 11 p.m. So it's 3 hours on a Saturday and 3 hours on a Sunday. Okay, so it's basically 6 hours on a one weekend, and it takes entirely 1.5 months to cover the entire R programming from basic to advanced. And obviously if you go for a weekday, that will be in the morning 7 a.m. to 9 a.m. And though in that stage it will be a Tuesday, Wednesday, Thursday and Friday, 4 days, and it will be totally 8 hours session in a week. Okay, so obviously if you go for a weekday, the time consumed will be less by you, so you'll be able to complete the batch very soon. Okay, but the main focus we keep ahead in the entire training is not just the industrial knowledge, because having the knowledge you can get from anywhere, from any you just Google out or YouTube do the regarding the R programming, you'll get the knowledge. Okay, but the thing is, the R programming tutorial or probably the training which we provide is given by a trainer. He is basically a trainer, a working professional in the industry. Companies like working in IBM and Microsoft. He is already working on R programming and data science domain for more than 10 plus experience. So he's basically the trainer we normally choose for R programming and data science domain. So that person is going to train you from basic to advanced on these particular days. Okay, and we mostly focus on the real-time industry project. Okay, why? Because after doing the course, nobody wants to just do the course for the sake of knowledge, because these are something professional courses. You are obviously looking for a job or probably to upgrade yourself in a data science domain where R programming is being used. Okay, so 70% of the course is most widely focused on the real-time scenario projects where R programming is used in data science domain. Okay, so as the class is basically going on, you will be getting a real-time industry projects and the software, because it's a basically open source tool. So you'll be working on a real-time industry projects apart from the online classroom session with the trainer. And it's basically an interactive session where you can talk with the trainer, you can ask your doubts and queries at the same time. Okay, and every session is also going to be recorded, and you'll be getting the recording session of each session. Okay, so even if you miss the class, no issue, you'll be having a recording session, you can go through that, and then my support team of a data science technical team, they'll be going to help you out apart from trainer. But the main thing is when you work on this particular project, you understand that what is the practical use of this particular programming language when I get a job, or when I look for a job in the industry probably the next 5 years down the line. You'll be able to understand. So what is the benefit of working on these projects which you provide? So benefit is this: once the course has been done, even if you're a fresher in a third year or a fourth year in a college, after this entire course, you are no more fresher in R programming. Your knowledge will be equivalent to a 6 month of experience guy who is working in R programming. That is the main USP of doing this particular training on R programming. Okay, that is going to help you out during the time of interview. When any person is going to ask you any question on R programming, obviously you're going to answer because you have the industrial knowledge. But when you mention that I have worked on projects regarding the R programming, okay, so you will be able to understand that, okay, I have worked on the real-time industry project on R programming. I know how to work. I know how to use a tool used in R programming. So when a person is taking interview, he is able to understand, okay, this person has a practical knowledge. Okay, so I don't need to invest my money and time. That's the any organization. Nobody wants these days to invest their time and money to train you. Okay, so having a knowledge on industrial base and the practical knowledge while working on the project is going to get you a sure shot job in the industry. That is the main requirement right now. Whenever HR person hiring technical person, have you worked on a project or not? Okay, and that's we keep focus during the entire training. Okay, and once the entire training has been done, obviously you'll be getting our own certification, which is globally recognized, because we also provide corporate trainings on data science, on artificial intelligence, Python and R. Maybe in the future, if you would go ahead, we'll conduct a live session also again on Python, on AI, these courses, because there's something very trendy technologies in the industry. Okay, so for that, if you will be going ahead, I'm as a senior course advisor here in the data science, you'll be getting a flat 10% more discount on that, and obviously you'll be learning a grade in this particular domain, which is going to help you out not only right now, for the next 5 to 10 years in the industry. Okay, so my team is going to help you out right now with the Google submission form, where you can put up your name, phone number and email ID, and just you need to submit, and very soon we'll be connecting you back so that we can provide you the best scheduled batches which you're looking for, and best price also for that. Okay, thank you, thanks all, good night.